Good morning and welcome to the second day of the Smalltalks 2015 conference here in Buenos Aires. I'm pleased to welcome you to our 9th annual event and participate. I am James Foster. I am with GemTalk Systems, and I am going to give a brief introduction to GemStone and a review of the state of the product and a roadmap for what may be coming soon and later on after soon. Our agenda, introduction, and then about GemTalk, product roadmap, licensing options, and questions. So an introduction to GemStone. Most of us here are familiar with Smalltalk, and the idiosyncrasy of Smalltalk is the image-based development. So the fact that everything tends to be tied in with the central environment. Smalltalk is an environment, not just a language, where an object represents a combination of behavior and properties. Each object is an instance of a class, and the object space represents what you might think of as RAM in a virtual machine. And the image represents the disk in that context and is a persistent copy of memory when the system is not active. Smalltalk is distinguished as being an all-inclusive environment, which we find very friendly and helpful. Developers often like to make and modify their tools, and having an environment where that flexibility is possible is very nice. Smalltalk was actually designed in part to allow research into program design. So that gives us an environment where we can experiment with ideas about programming. We develop by modifying an existing environment, and copying or cloning that environment gives us a new environment to work with. Everything is an object, simple, elegant language, and powerful class libraries. There are some limitations, however, of the traditional approach to Smalltalk. The object space must fit into RAM, or virtual RAM, if you're using that concept. The object space is visible to only one virtual machine. And when you copy it, take it somewhere else, that second virtual machine has its own separate copy. Sharing objects between virtual machines is difficult in the sense that there is not an identity preserved. You can export and import a variety of formats, but if you export then import, what you get back in is not the identical object in general. And of course, when your virtual machine exits, you lose your object state. So GemStone is a system that is based in Smalltalk, but has a number of features that we will look at in a little bit more detail here. First, it is a multi-user object server. Scalable so that we can run thousands of concurrent user sessions in one object space. And the folks yesterday, I wouldn't be able to say this except they already said it. JP Morgan is running hundreds or thousands of virtual machines connected to one object space. On hundreds of hosts, the object space or image can be terabytes in size or more. Thousands of transactions per second is possible with this system. Concurrency. Multiple user sessions may be active at one time. Each user can have multiple sessions. And you can have separated or shared namespaces. GemStone, I think, was the first Smalltalk to have namespaces, and that allows each user to have a separate set of globals that they have visible. Changes to objects, instead of snapshotting the entire memory image. Changes are based on transactions and are written out. Each transaction has a commit. And concurrency controls are available to allow for coordination between sessions. There is user-based security, so each user can have a separate login ID and password, much like a traditional database. Each user can have a separate global list or namespace visibility. There are system operations that can be secured by user permission. So the right to make a backup, the right to change passwords, your own or someone else's, is limited by security. And then finally, there's a per-object read-write permission that can be user-based or group-based, so that you can put multiple users into a database and the virtual machine will enforce the limit of this user is not permitted to read or send messages to this object. It's a programmable database, but rather than just embedded SQL or something that's like that, we have Smalltalk as the embedded programming language. For data definition, again, the way you describe your schema, send messages to classes, to create methods, and so on. Object manipulation, query facilities, rather than some sort of new special query language, just use Smalltalk, select, detect, collect, and so on. Concurrency management, system management. Doing a backup is done by sending messages to objects in Smalltalk. Restoring from a backup, getting a new transaction log. These are all Smalltalk operations, not separate database management scripts. There's a large-scale object space, limited only by disk size. The system handles RAM caching, as databases generally do, to provide that optimization. The object space is shared by all connected sessions. Each session gets a view of the database based on the last commit or abort that that session has. Persistence, again, when Smalltalk is if an object is reachable from a persistent root, then it's not garbage collected. So instead of some complex approach for writing, adding something to a database, you just say collection, add, object, and it becomes persistent. On a commit, your new and changed objects are visible to other sessions, and you get visibility to all the changes that have been made since you started. Transaction semantics. Again, if you've done computer science database classes, there's a whole series of characteristics that are expected of a database. The database view is isolated with repeatable reads. So changes that other people make don't affect your view of the database until you reach a boundary of a commit or abort. Committed changes made by others are hidden. On abort, the current view is reset to the current state. So you can move up to the most recent, including objects that were changed. And if you do an abort, you can abandon your changes and see what others have done. System management. The system can stay up 24/7. Our friends at JP Morgan described clients, customers, users around the world that access the system. And so the system is up 24 hours, 7 days a week. You can do online backups, and it will take the transactions as they occur. A restore, including transaction logs, or what some databases call replay logs, are available. Shared memory is used to cache recently used or frequently used objects, so that you don't have the delay of going to disk if someone else has recently written things. The slowest part of most database operations is disk, and If you are running the database just on a local laptop, then of course everything is going to and from the one disk. In a larger production context, it's common to set up multiple disks, and the system is smart enough to say we can write to each of the disks in parallel. So the system will find something that needs to be written, start a write to this disk, find something else that it can start writing to that disk. So keeping things clean in memory, on disk, optimization, asynchronous I/O to parallelize the disk writes. Hosts can be added or removed to a running system so that if you want to scale, you don't have to take the system down and bring it back up. You can simply add a new host to a running system, and it will then be available for others to use. Monitoring and tuning, lots of statistics are available, can be accessed from Smalltalk or taken and written to a file for later analysis. So that's a brief introduction to GemStone as the Smalltalk system. Several of us are here who would be delighted to talk with you about that further if you have questions. GemTalk is the current name of the company that owns Smalltalk. There's a great deal more continuity than it would appear from saying that we're a 3-year-old company. Serviologic was started in 1982 to build an object database. In 1986, they did a demo of GemStone at the very first OOPSLA. OOPSLA was, for many years, the premier object-oriented programming systems, languages, and applications event. In 1995, the company was renamed GemStone Systems, Inc. Some of you may remember or have heard about the big dot-com bubble that occurred in the late 1990s, around 2000. Brocat Technologies was one of the shining stars of that era and grew rapidly, including by acquiring other companies. They bought GemStone Systems and several others in 2000. This was a Germany-based company. I think less than a year after they bought it, they went bankrupt, and GemStone was reborn in its second iteration in 2001. And then continued the development of the GemStone Smalltalk system. In 2010, the company was purchased by VMware. VMware was in a growth trajectory at the time and purchased it to acquire the GemFire system that had been developed recently by GemStone. GemFire was a Java-based memory caching system that allowed performance optimizations for Java applications. And VMware was interested in that, purchased the company. In 2013, we became the first divestiture ever made from VMware. And when we joined in 2010, VMware had about 8,000 employees. When 3 years later, they had about 14,000 employees, and then acquired a new chief executive. And for those of you who have any experience in business, MBA type language, we switched. VMware started with a emphasis on collaboration, things that can be done together, and acquiring synergies was the buzzword. We have synergies by having different things together. And 3 years later, a new chief executive came in, and his mantra was core competencies. And the core competencies idea is find something you're good at and stick with it. Don't try to branch out. So something that VMware decided that they weren't in the business of was Smalltalk virtual machine databases. And so we were their first spin-off. We were acquired by GemTalk Systems LLC. This was a company created by one of the founders of the second GemTalk Systems. And so the Dan Ware, who came here, I think, 3 years ago to Smalltalks conference, and it's set up the company, acquired the business and the team, hired all the engineers, and went around to the customers, reassuring them that we had the same people that had built the product over the past 3 decades, and we would continue supporting them in that way. Of course, the salesman then stopped talking about being on an aircraft carrier and started talking about being on a speedboat. So we can, rather than being a big, reliable company, we're a nimble, reliable company. And there were some companies, we had to do a certain amount of renegotiating contracts, and there are bigger companies who find some comfort in being in the arms of a 10,000 or 15,000 person vendor, and a little less in being in a 15-person company. But I think for those of us who have been through the experience, we're now a company that is single-mindedly focused on Smalltalk. And if the Smalltalk GemStone product is not going to do well, the company will fail. And so you have our undivided attention at this point, rather than being a tiny part of a very big company where the salesmen haven't even heard of the product. So that's where we are. Recent and planned releases, starting with 32-bit. 32-bit is the legacy product that has been out from the beginning. 6.6.5 version was released in July of 2014, so it's a little bit more mature there. We have a 6.7 pending that has a few minimal updates in it, but does address a few issues that people need. In the 64-bit, this is where most of our work has been. 64-bit expands the memory space, the disk space, the number of objects that we can hold, and a number of things. 2.4.6 was released in December of 2013, and 2.4.7 is pending, increases the maximum number of sessions. One of the things that we do, as I mentioned earlier, we keep a cache in memory of the recently read objects and recently accessed. As memory expands and becomes available, we and our customers like to increase the size of this in-memory cache. And when the operating system is keeping track of pages that have been allocated to processes, the default page size has been 4K. And if you're getting into a cache that is tens or hundreds of gigabytes in size, the table allocation structure and the memory needed just to manage the table for how many 4K pages have been allocated is quite extensive. And so by going to large pages with 2 meg, we can significantly reduce the overhead in the operating system of managing these large caches. 3.1 was last updated in April of 2014. 3.2 is the current latest available 64-bit release. And we've had so far 11 small updates to that in the last couple years. And expect or had one just earlier this month. There's features there including the large page, multi-threaded operations to improve performance on multi-CPU machines. Indexing received a good facelift in 3.2, and there's more support for Unicode. Our internationalization has improved. We've been continuing to work on Unicode support. Petty parser. I mentioned earlier, in the last slide, the indexing API is now actually uses petty parser to parse some of the queries to the indexing system. And by bringing that in, we now are providing petty parser as part of our base image and using it in a few other things. 3.3 is the release that we're currently in code freeze on and doing the QA cycle. So each week or each day we say, well, this is code freeze, but then of course QA cycle continues. And so that's expected to go on for a bit longer, but we do hope to have 3.3 out this quarter, so by the end of this year. Improved native code generation. So we have a JIT compiler that takes the Smalltalk that you provide and compiles it down to assembly language. And we've gotten a decent 25% improvement in performance, we find, on our benchmarks. Particularly math and integer math will be improved. Transaction logs restoring has been optimized, about 30% improvements. And for those who are running a hot standby system where each record is applied, this can improve performance. One of the things people have asked for is the access to the Unix system log, so that you can now add messages to the syslog through an API here, a new class that handles that. One of the things that going to 64 bits does is it gives us a larger number of bits for immediate objects. So I think most or all Smalltalks optimize small integer, Boolean, nil characters into a immediate object. So instead of being a pointer to the object or data based on bits, flags, we can just say, well, of the 64 bits, 3 are flags and 61 bits is available for other things, either the object ID or pointer or something else meaningful. So small fractions is now something we've added to as an immediate object. So this reduces the memory space taken and makes them identical if you do comparisons, as long as they're in a particular numeric range. And then, of course, there's automatic translation to large fractions if you go out of that range. We have small doubles as well that was added as part of the 64-bit. GS file, again, UTF-8 support. Data compression. We have been using gzip for certain compression operations, but it's nice to be able to take advantage of improvements that others are doing in this environment. And so there's something, LZ4 is a lossless compression algorithm that can improve performance at a only slightly increase in the size. So it's not quite as efficient on the compression, but much faster. So we're looking at using that for communication so that we reduce the traffic over the network between client and server. We are going to provide a way to encrypt the traffic between the gem and the page server. And again, larger operations, particularly with confidential information, are looking for things like this. Commit record disposal. You can signal a session, please update your view of the database. If you do this one at a time, it can involve a bit of a lag. Here we have the ability, if you have lots of sessions with many of them idle, to send kind of a blanket to a number of them saying, please update your view. I mentioned we capture a lot of statistics. One of the things that we often ask customers or users when they have trouble is, well, do you have statistics that showed what was happening at this time? Oh, well, no. Should I be capturing statistics? Yes. So we encourage you to do that and now have a way of starting it automatically when the stone starts. Page audit can be multi-threaded. We have a canonicalization framework that we built working together with one of our customers. This is something where you have certain objects like date, time, or maybe something unique to your particular domain where you want to have identical objects. You want to have only one of them in the database, even if it appears to get created multiple times. This is a framework that if you request new objects in a particular way, that it will attempt to provide a single canonical object in this situation, which can reduce things like date, time, instances dramatically. LDAP authentication, page server, have some new architecture. I'm going to run through a few of these because our time is limited. We have kind of experimental projects that someone has compiled the GCI library for Android. Use GemBuilder for Java is available and communicates so that, for example, here is a IP address, port, stone name, username, password, and a login button. And then there is a text entry field where you can type a Smalltalk expression and then execute it and get back the result of executing that Smalltalk. This is available through this FTP site, and if you have questions on it and want to play with it, we have a few people that are toying with an Android. We have some VSD improvements. And we support, for 3.3, the upcoming release, we'll support Linux, Macintosh, Oracle Solaris on Intel, Oracle on SPARC, IBM. We support VisualWorks clients and VA clients from Syncom and instantiations. Other things we can do in 3.4, we want to hear ideas and requests. And one of the things people talk about is login. We currently have database user ID and password, LDAP, Unix, PAM authentication. But there are other things that could be done, but we need to hear from people that this is something that you need and would put into use. GemBuilder is our client-side library that provides access to the database, where most of our customers are working with Syncom or with instantiations clients to access GemStone. Licensing, perpetual, buy once. Annual subscription, lower fees on a repeat basis. If you're building an application and selling it, a VAR arrangement with a percentage of royalties. And those are all negotiable. We have a community edition, and this information is available on the website. There's a key that's provided with the download that allows certain use. If you want to increase that use, there's all you do is send an email, and then there's prices for going up from there. So, questions, and the next talk is welcome to come and start getting set up. I know we're going to try to keep things moving. Yes?
Yes. Why did you select it to do small structure and minute objects and not, for example, date or date time that it looks like there are more objects than that?
I think the best thing to say is just that was what some of our customers needed most, And we had some who were doing, particularly in the context of some mathematical operations, that was something that they had extensive needs for. But yes, date, time. Martin has pointed out that if you went with the number of milliseconds since the microseconds since the Big Bang, you could fit that into 61 bits. So yes, that would be an obvious addition. Yes?
Manage single instances
Yes.
for domain objects. It's just for mutable objects or object.
Yes, I believe that the object needs to be immutable. So that it, yes.
Something I always wonder with GemStone is why is VSD not implemented in Smalltalk? Are there any plans?
Why is VSD not implemented in Smalltalk? Largely historical in the sense that there's two parts to the VSD. VSD is Visual Statistics Display, and the keyword there is display. And since GemStone does not have a native graphical user interface, the display part is a bit harder to do in Smalltalk. Now, of course, it could be done in a client. As it happens, I have a project on GitHub called Web Tools that provides VSD-like functionality through a web browser. And so if there were interest in that, I would be delighted to talk with you more and discuss it further. But I think maybe I'll pass things over to the next one. And yes, okay. You see?